to introduce you to my master thesis titled Influence of Rainfall Patterns on Runoff Generation Mechanisms in headwater catchments within the Mexican Neovolcanic Belt. These are my supervisors, Jorin Vonk and Sampurna Ramsdale. And yeah, I'm going to try to be concise and go to the point. Well, first of all, yeah, runoff generation mechanisms is a wide field studied by hydrologists, and headwater catchments, as the catchment we have in our study site, are very targeted catchments in order to develop this kind of studies, because they are an important part in the local hydrological dynamic system. And what I want to reintroduce into my study, and it tells you how the precipitation water will end up in the stream, and which flow paths does the water pass during its process. So we have considered four main components. These are precipitation, which is the P, soil water, groundwater, and in the end is the stream water, which is runoff. Those three components are mixed in order to end up in the stream. So in the end we will study the runoff generation. First I'm going to introduce you in the research area. We are in central Mexico, the state of Michoacán. It's in this area. And the Alto Fresno Hydrological Station, we will call it from now on AFRES. It's located within the Cuitzeo Lake Basin, and it's a tributary of Rio Grande de Morelia. It's located in the south part of the city of Morelia, and it consists in two catchments. It's C1 catchment and C2 catchment. My study is focused in the first catchment, which is a forested catchment. It's naturally regrowth from a former gully, whereas the second catchment is just an agricultural catchment. Geologically, this area belongs to the Mexican Neovolcanic Belt, and the main material here is the Vrije. It's impermeable volcanic rock, and over this bedrock, the soil has developed and formed in three main horizons. The horizon A is the organic Greek horizon, and it's the southwest horizon. Overlies this BT horizon, which is a clay-rich horizon. We consider this study as impermeable horizon. And underneath this, we have the saprolite, which is the first weathering product of the evening brite. Yeah, and that's it. So now we're going to focus on climate. This is an important part of the research, because we are counting how the rainfall is influencing in the stream runoff. We are in a temperate subhumid climate, and it's classified as CWP within the Köfferling classification soils. The mean annual precipitation is around 1,000 millimeters, but it's very variable since there are some other processes that can affect it. And we have observed two main kinds of precipitation events. These are like the cyclonic events, are events which are developed in the ocean. So we have a low pressure system, and evaporation enhances the formation of these systems, and then when they come inland, these rain events occur. These systems we have observed that they are mainly very elongated in time, and normally with low rainfall intensity, but they are also extreme events. And on the other hand, we have convective events, which are events locally formed through evapotranspiration processes inland. Normally these air masses are lifted up very quickly, and sometimes it reaches the condensation point, and it drains out very quickly as well. So we have short events with very high rainfall intensity. These patterns are always influenced by some cyclical phenomena like the ENSO, which is El Niño Southern Oscillation. This year, the NASA observed that there was anomalies in the sea surface temperature, so they defined 2015 as an El Niño year. And more over that, this El Niño was the strongest ever recorded yeah, this is because, well, two main, yeah, I can show you two main pictures of this. Why is it it was very strong? This is a picture taken from NASA on the 1st of September. You can see in the Pacific Ocean there were 4 simultaneous tropical storms at the same time, which we never recorded before. And also in from 20th to 24th of October, there is this big hurricane formed very close to Mexican coastline. Hurricane Patricia, it was a category 5 hurricane, and it was the second most strongest hurricane recorded. And it was, yeah, the special thing, it was very fast formation, and made landfall on the 23rd of October. Here is the apex. It is our research area. It's located around 400 kilometers from our research area. So we have also some influences of the hurricane. Why do we do this study? Okay, the apex is located in this mountainous area in southern Morelia. This area, as well as this area, are the main research area of the aquifer system in Morelia. So yeah, this is very strategic for this location. And also another very important justification for these projects are that in these tropical areas are very sensitive to the occurrence of these very extreme events caused by tropical cyclones. And this is my concern for the authorities because, yeah, it has a very destructive potential. And you can see here, these are pictures from last week. There was a hurricane who made landfall in Mexico, in central Mexico, from the Atlantic Ocean. And you can see here the floods and mudslides, which are, yeah, they can cause fatalities in this area. So, what's the objective of this thesis? Okay, well, we wanted to evaluate the runoff generation mechanisms as a response to rainfall events on a seasonal basis and on an event basis. On a seasonal basis, what we want is to assess if the stream flow is a mixture between the components I told you before, precipitation, soil water, and groundwater. And we can also calculate the mean residence times in the catchment. And on an event basis, we have divided this in two main methods, the graphical methods and the geochemical methods. With the graphical methods, we can get information about the contribution from direct runoff and delayed runoff. And the geochemical methods will help us to calculate or quantify the contribution of those components. Well, these are the research questions, are almost the same. In a seasonal basis, how are these components contributing in stream water in order to generate runoff? Our hypothesis said that stream flow in a seasonal basis will be a mixture with groundwater, soil water, and precipitation, with major contribution of groundwater under baseflow conditions. And as long as the rainy season progresses, we expect to have more contribution of precipitation and soil water. On an event basis, what we expected at the beginning is like dissolution processes caused by an increase of precipitation water in stream water, like contribution. And if we had big events with very high rainfall intensity and antecedent moisture conditions were also high, but we expected here it's to have a very high peak flow. And linked to this, we have this third question, which is how this response, event-based response, can be caused by extreme events. So we expect to have very high contribution from precipitation component and very high peak flows as well. Now I'm going to introduce you into my methods. Sampling was carried out between May and October 2015, the rainy season in Mexico. And we sampled two main characters. Like we did physicochemical monitoring and stable isotopes sampling. With the physicochemical monitoring, we analyzed electrical conductivity, dissolved solids, suspended solids, pH, dissolved oxygen, temperature, and chloride, and we took 2 samples per month. For the isotope sampling, what we did is calculate the concentration of deuterium and oxygen in the sample. We took one sample a month, and we sent them to the University of Saskatchewan when they did the analysis, and they gave up the result. With those results, what we wanted to analyze is mixing in spring water through these mass balance equations in order to calculate, as I already told, how is the contribution of each component to the stream. Now these are just pictures of how it was made. Those three components contributing in the stream flow, and yeah, we studied this in two different kind of set of analysis. From May to July, soil water was very not very high, so we didn't get enough yield in order to get samples. So we did a two-component model, old versus new water. From August, we could sample soil water. We had enough yield to get samples, so we added a new component, the soil water component. And now we go to results. This is the PQ relationship during 2015 in a 10-minute basis. What we can see here, this is the main part of the rainy season. What we can see here is the catchment is a small catchment, so it responds very fast to the rain events. But the major pattern is that the discharge remained more or less constant during the season, regardless of peak flows. So this tells us that the water leaves the catchment very quickly. In a seasonal basis, we did physicochemical monitoring, told us, like using DDC and CDS, which were the more reliable parameters we used. That one, I'm going to go very quickly, we can go maybe afterwards more in detail. But the green line is the stream water. You can see that it was very close to groundwater as we expected. It has some contribution of precipitation water, which is the blue line. And the most interesting part is by the end of the rainy season, in the month of September, the stream water went up. And it was approaching the characteristics of soil water, which indicates us that soil water, by the end of the rainy season, started to be an important contribution to stream water. The isotopes analysis told us more or less the same. Stream water, which is the green triangle, was very close to groundwater, and by the end of the rainy season, in the month of September, it was very close to soil water samples as well, which corroborates that soil water was, by the end of the season, when soil was wetting up after the rainy season, was a big contribution. Now we go event-based, and we go through the graphical methods. For the graphical methods, we studied it based in 4 factors that are controlling the runoff generation. These factors are the kind of precipitation event, which tell us like if there are like big events in duration of time, and with high intensity or low intensity, the rainfall size, seasonality, and the antecedent wetness conditions of the catchment. For the type of precipitation event, we can see that cyclonic events, what I told you, they are elongated in time and with low rainfall intensity. They have around 70% of delayed flow, whereas convective events were more or less the same. Dealing with the rainfall size, we can see that the biggest the rainfall size was, the biggest the contribution from direct runoff was in the stream flow. And comparing dry and wet seasons, the dry season was much more influenced by delayed flow, and in the wet season it was getting more close to each other. Here you can see, just to show you how is the difference between a cyclonic and a convective event. The rainfall is 3 times bigger in the cyclonic events, but the response is 10 times bigger. And now I'm going to geochemical methods. So there were 3 events that they were monitored. Here is one convective event. I'm going very fast with the physicochemical parameters. But you can see that here, these parameters are getting lowered after the highest rainfall intensity. This might mean that there's already a big contribution from rainwater in the stream. So the stream is responding, increasing discharge and decreasing or having the attenuation of these factors. So yeah, we expect that during the rising leap of the hydrograph, there is more contribution of rainwater, and then it seems that it goes back to the baseflow conditions. applying the mass balance with the isotope data, this is corroborated. Here we have larger contribution of stream water during the rising limb, but the main contribution is still from groundwater. Now we go to cyclonic events. This was an extreme event. This is Hurricane Patricia in Aves. The rainfall size was over 70 millimeters, and you can see that from EC and TDS there was this dilution effect that these were getting attenuated, and with chloride and suspended solids, we can say that the rainfall intensity had a very big influence as well. But the trend is that both of them are increasing as long as the event progresses. We could not sample the whole event because it was already night, it was dangerous and stuff. But yeah, this what we can say here is from the beginning there is a contribution of a higher contribution of groundwater in the stream, and as long as the soil was getting saturated, by the end what we expect here, for example, at this pitch flow is like the majority of water is rainwater, is new water in the stream. This is what tells us as well with the isotope data we could not make the hydrograph separation, but we still can see that stream water was very close to groundwater values, and then we were getting depleted going towards rainwater. So there is increasing indeed contribution from rainwater. So now we go to conclusions. As we already told, the stream water behaves as groundwater under base flow conditions. So groundwater normally is discharging in the river, and by the end of August and September there is high contribution of soil water, and we could see it in the field because we could see some exfiltration areas. So we could see some soil water exfiltrating from soil and going towards the river. And on an event basis, we can say that convective events has first a very high contribution from precipitation water as saturation overload flow and some precipitation. And as long as the event progressed, there is higher groundwater contribution. Infiltrating water from the event is pushing out groundwater into stream. And then for Hurricane Patricia, what we could say is there is, during the event it was a big groundwater contribution, and when the topsoil was getting close to saturation, there was an increase in stream water on the river. So now this is like a conceptual model I did, but yeah, it tells us more or less the same. This is like an input from rainfall, and this is water traveling through soil. So there is this subsurface through flow. And here is like the rainwater when the soil is getting saturated, and it's the soft contribution. We also have the tidal precipitation and the groundwater discharge. These are the main contributors in the river. So yeah, we can go through it in more detail, but for the moment I think it's nice to see. Yeah, and then there are further activities. I'm not going to focus on this, but in Aves what we need is to have to increase the sample size in order to make statistics. And therefore, we can say that in such areas, in these tropical areas, how it's runoff is generating. And yeah, that was all for the end. This is a nice view from the catchment. Thank you for your attention.